factorable of last lesson? How do you solve the equation that is not factorable?
So if we are looking at something that's not factorable, okay, up to this point and on your quiz, some of you estimated that solution for me. And when you estimated the solution, some of you told me exactly what you thought it was, and it did come out as decimals on both of them for that bonus question. But if we are looking at this question and it's not factorable, what you want to put down first in your notes is this. We want to take a look at. We need to rewrite the equation so that it is factorable. So your first step when we take a look at this today is when we are looking at an equation, if it's not factorable, we're going to be working with what's called this new method called completing the square. You are going to rewrite it in a factorable form. We can do that by adding or subtracting the same amount to both sides of the equation. If we add a number to the right, if we add the right number, we can then rewrite our equation, and this is the best part, as a perfect square trinomial. Keeping in mind, that means when you have ax squared plus if we are looking at our terms, you had 2ab times the x, plus back here was your b squared, and we're going to keep it equal to 0. So when we take a look at those, this method can help us out quite a bit. And what we are going to do, because we get these ugly decimal answers, they do not come out to be nice answers. And since they don't come out to be nice answers, we need a different method of solving them. So this method called completing the square is what we're going to do. Key thing is we are trying to make it factorable. Okay? So remember, if we are trying to make it an equation that is going to be able to be factored, we want to think of writing that. Remember, when we factor this, a lot of times this is where you had your difference of two squares, where you had ax plus b squared equals 0. So if it is a plus, or sometimes you had it as a minus, if this was a minus, if it was a minus, how did you factor it? You had ax, and then you had minus b, and you had that whole thing squared equals 0. Now, you did have a question like this on your quiz. The first one on your quiz came out to be, and I think everyone in here took the quiz, I think you had something like x squared plus, what was the equation? Plus 16, x plus 64 was equal to 0. This is factorable, right, as something squared. And this is what some of you had. You said it's in this form. At ax squared, which means it's just going to be x, we're going to take the square root of 64. The square root of 64 is 8. And since it's a plus, you had a plus, and you had it equal to 0. And when you solve this, some of you did an awesome job. You said, well, if x plus 8 equals 0, the answer is not 8, right? The answer was negative 8. Now, some of you tried to tell me there was two answers, negative 8 and positive 8. If I plug in positive 8 here, it doesn't equal 0. If I plug in positive 8 back here, it doesn't equal 0. The only thing that works was negative 8, okay? And so today, this is the key thing. We want to get our equations like this. And we're going to start with some easy ones that we can. So this is how they explain completing the square. My other suggestion, as I put on the daily planner, was that if you look at this, and this still doesn't make a lot of sense, go to Khan Academy, go to YouTube and search completing the square with quadratics. If this just doesn't make sense to you, and it's kind of hard for a lot of people at first, go and look at other resources to help you out. So when we are looking at this, we can't factor two things that multiply to 16 and add to negative 14. There is just, as we start looking at that, there's no nice numbers, right? So since we don't have two numbers that easily multiply to 16 and add to negative 14, first step, we are going to subtract this 16 from both sides. So x squared minus 14x is equal to negative 16. Where that b over 2, remember that was kind of part of our vertex, we're going to take So in this equation, remember, it is always A, in this case, would be 1. Our B would have been negative 14. And we don't have a C anymore. So we take B divided by 2, which in our case, they wrote over here, is at negative, if we are looking at that, negative 14 divided by 2, and we're squaring it. Gives us 49. 49 is what we have to add to both sides of our equation. So we add 49 on this side to negative 16, and we add 49 over here. Now, when I look at 49 on this side, what I'm really looking at is doing that factored form, which was the AX, and it's minus this B divided by 2, right? This is B divided by 2. 14 divided by 2 is 7. So whatever you get in this parenthesis before you square it, that's kind of what we are looking for. That'll be x minus 7 squared. We add those two together equal 33. So x minus 7 has to equal positive and negative square root of that. That's how we get our decimals. This is not an exact answer. We're rounding it, right, to 2 decimal places. We then set each one equal. X minus 7 can equal 5.74. X minus 7 can equal the negative. And we're going to add to both sides, okay? And I know just looking at it and not actually doing it sometimes doesn't make as much sense. So it says, notice the original problem was not factorable, so we added 49 to both sides. Now the left side is factorable because we now have the yellow highlighted part is a perfect square trinomial. It is one of those special factoring patterns that we learned earlier this year. Once we factor it, we can solve it simply by taking the square root of each side of the variable. So this is kind of going to be key to what the completing the square is about. So, as we are taking a look at this problem, first thing, multiplying two things to get negative 20 and add to 12. If we start thinking of things, negative 20, we have 10 and 2, but one has to be positive, one negative, we need positive 12, right? If we have 4 and 5, that doesn't work, 10 and 20 and 1 doesn't work. So as we start this problem out, what you're going to do in your homework is you're going to rewrite it as x squared plus 12x. We're going to put plus, we're going to leave a space here, is equal to 20, right? How did we get 20? Because we have to add 20 to both sides. And we are trying to figure out what we have to add to both sides. What you decide to add to both sides is that you take the b term and you divide it by 2, and then we're going to square it. So if I am looking at this one, this is my a, right? A is 1, b is 12, and I'm trying to figure out this one. So I take b divided by 2. Kylie, b divided by 2, what is my b value? 6. So I have 12 divided by 2, and it does give me, if I'm looking at that, 12 divided by 2 gives me 6 squared. So what do I have to add to both sides? 6 squared. So I need to add not 6, but 36 to both sides. So I add 36 on this side, and I get it's equal to 56. I am now trying to factor this as something squared. So this is where I take the square root of my a, which is just x, and I take the square root of 36, which is just this number, right? And that's kind of what I want you to notice is that whatever number this is 6, that's kind of the same thing that's going to go right here. So we are going to have a plus 6 squared equals 56. This is kind of our vertex form. Remember when we did those equations? If I would have asked you to find it in vertex form. This is almost in vertex form, okay? So last week we kind of talked about this. We're going to get this more because we do completing the square this week for both days of school that we have, and then we have 2 days where you don't have school and no school Friday. So next week we'll get into the different forms, standard form, vertex form. If we look at this, our next step is we need to put x plus 6 equals, and this is where some of you forgot that you have 2 answers when you did the quiz, and you just said, oh, it equals the square root of 56, but please make sure you put that plus and minus in front. So now on your calculator, we are going to put x plus 6 is equal to the positive, and this time I just want you to put positive square root of 56. And over here, our other solution is x plus 6, still again, is equal to the negative square root of 56. So you do need to take the calculator out and find the square root of 56. In order to solve this one, we are going to be subtracting 6. So x is going to be equal to the square root of 56 minus 6. So be ready to tell me that approximate solution. Usually we go to two decimal places. Here, we're going to be subtracting 6 also from both sides. So on your calculator, x is equal to negative square root of 56 and then minus 6. So again, x is approximately equal. Check with your shoulder partner. One's really close to 0 and one's a little further away for your two answers. Put them in your calculator. So one actually comes out to be positive, right? Addison and Grace, want to give me the first one? 1.48331. We're going to stop at 1.48. So approximately, x is approximately 1.48. Okay. My other answer, Lauren and Ryan, negative 13.4. Okay. We get them both. Putting it in your calculator. Square root 56, put that in, leave the decimal, subtract 6. Then it's the opposite of that, the negative square root of 56. If I would have asked you to graph this parabola, right, this is telling us that one answer is way over here at negative 13.48, right? That's where one of them is. And the other one is right here at 1.48, comma 0. That's what they are telling us when we solve. It's the roots, it's the solution. Would this be a parabola if I asked you to graph it looking at the original one? Would it be a parabola going up or going down? It would have been up. And so, like, this would have been way down here. And that vertex would be way kind of in the middle so that it would be like this, the axis of symmetry. Some of you didn't draw that line on your quiz, which was unfortunate because it's like a point. And the direction said draw it. So this is what that solution means when you're looking at that. And they're not nice numbers, okay? So this one comes out again as a kind of ugly decimal, so we're going to start it off together. So x squared plus 9x, we're going to subtract 15 from both sides. We're trying to figure out what do we have to add to both sides. So please take b divided by 2 that we are squaring, which means I am taking 9 divided by 2 and squaring. Now, when I look at 9 divided by 2, 9 divided by 2 squared comes out to be 81 over 4, right? That's what I'm adding to both sides. I am adding 81 fourths. I'm adding this number is the number that I'm adding to both sides. Okay? Can you put it as a decimal? You can, but I'd leave it like this right now. I would not change it that way. Okay? I'd leave it like this, and I'm going to tell you why as we go into the next part. Here's the other part. I am now looking at saying something squared equals. Now on this side, definitely. If I want to add these together, I might get that. Let's get a common denominator of 4. What would a common denominator of 4, what would I be looking at? So this is 15 over 1, right? So if I multiply them both by 4. So tell me how many fourths you're going to have here when you subtract or add those. okay? Should come out to be how many? 20, 21. Did everyone see how we got 21? You get a common denominator of these two before you add them together instead of doing them as decimals, okay? I am okay if you decide to just put it in your calculator, and then you would have had what? 20? 21 fourths is how much?
20.25.
Okay, oh man, that was worrying me with 20, okay, 5 point what? There we go. These are the same two things, right? You agree? Phew, that other one was confusing me a little. All right. When I go here, though, I want to leave this as a fraction. I want to put x plus, and what do I want to add? This is where I want to put in the b divided by 2. I want to leave it as 9 over 2, okay? So when I put this, this is x plus b is what we are always looking at, the b divided by 2, okay? So we're going to keep it like this. That whole thing was squared. Now, what's nice about that, and someone said, well, can't I put 4.5? You can. X plus 4.5 is equal to that. Is that now when we split it, x plus, I'm going to have that 4.5 or 9 divided by 2 has to be equal to the square root, right? Because we have to set it equal. So maybe before you have this step, you have x plus 4.5 equals the positive and negative square root of 5.25. So you go from the square to getting your square root, but there are two answers, 5.25. The other answer is x plus 4.5 is equal to the negative square root of 5.25. So with your shoulder partner, we're going to check. Subtract 4.5. X here is equal to the square root of 5.25. And then you're subtracting 4.5. They both come out to be negative. So here we are looking at negative square root of 5.25 minus 4.5. The first answer, what'd you get, Tate? No, grab one. They're up in front. Grab one. Georgia, did you get one? We're going to lunch when I got my two answers. Daniel, you got it?
X equals negative 2.2.
Negative 2.21 is our first answer. AJ, what'd you get for the second one? X equals negative 6.7. All right. Next thing you can do is just take and divide everything by 4, right? So if I need my lead coefficient to be 1, I can always divide everything by 4, and it is the same equation, right? Because 0 divided by 4 is still 0. And now my new equation is a squared minus 2a minus 6 equals 0. Now, some people will think, oh, I could factor this. Multiply to get negative 6, add to 2. 3 and 2 doesn't work, right? Now, there's some in your homework that you could factor, but you want to practice doing this method. So, from this point on, I want you to try it on your own, minus 2a. You want to think of what are you adding to both sides, equaling 6 plus adding on both sides. So that b divided by 2 squared. Okay? That's what you kind of got to be thinking as you start this. So, kind of look at. All right, let's talk about what did that first number have to be. What did my b divided by 2 squared have to be that I'm adding? Addison, what'd you get?
4.
What'd you get for b when you did this? What did you use for b in this equation right here?
Well, I did it before we simplified it, and
Okay.
I just divided that by 4.
Okay, let's go back. use this one. Tell me, and I want you to do this one too, because you can't do it if your lead coefficient isn't a 1. So the lead coefficient being 1, as you look at this, looking at my b divided by 2, what would you use? So b was
-2.
-2 divided by 2, and we're going to square that, which means I'm going to end up with
1.
this is going to be -1 squared, and what am I adding to both sides? I agree, I'm going to add a 1. Okay, does everyone agree? Okay, so Reese, I want to factor. What did you guys come up with your factors, you two? A minus 1 squared. Does that make sense? Equals on this side 7. Okay. Next step, I am going to be taking a minus 1 equals positive and negative. Like I said, some of you forgot that on your quiz. Square root 7. One's negative and one is positive for your answers, right? So when you are solving, a minus 1 equals square root 7. A minus 1 is equal to negative square root 7. If I ask for an exact solution, this would be it. Square root 7 minus 1. Usually we want approximate to 2 decimal places. Georgia, did you get the first one?
Well, wouldn't it be +1?
It would be +1. Thank you. Yep, it would be +1 because you were subtracting. First one, what'd you get?
3.65.
Yes. Avery, Kaylin, what'd you get for the second one?
-2.65.
No. Too big. Negative square root 7, and then add 1. Want to try it again? What you got? Am I off on mine?
-1.65.
Yeah, -1.65. Did everyone get those two answers when you put them in your calculator? Okay. If not, you need to make sure. So, when you are doing your homework tonight, these first ones, where it says 7 to 18 all you're trying to do is tell me the C value. Okay? My hint is, as you look at these, this one on completing the square flashcards, first one or the second one, I can't remember. I put 2 of them up here today. I think this completing the square, it kind of takes you through those flashcards of getting the answers for completing the square. But then it does say, well, what would I have to add to both sides? So they're really looking at you finding the 6 divided by 2, which would be 3, and squaring that. So what would you have to do to complete the square? You'd have to add 9. What would you have to add in this one to both sides? So some of those are really good ones to take a look at. And the other one, the second one that I put on there for completing the square, so I put another completing square. And I might have put it in the other class. I'll take a look. But there's another one that I have that's also really good with completing the square. Your homework for tonight that you are working on is page 579, 7 to 18. So when you write down the problem, 7 to 18, you are writing down the problem and then you're trying to tell me what C is. The C value, what you're really doing to find this value is taking B divided by 2 and squaring that. That's what that C is equal to. That's what I want to know. What would you add to both sides to complete the square? Down here, it says solve each equation by completing the square. If necessary, round to the nearest 10. So when you get down here, these are the ones that are more like your homework. Some of them are already set up. So like when I look at number 13, you are simply gonna write number 13 down as, and if you don't like using g squared, you wanna use x squared, I'm okay that you use x squared each time. X squared plus 7x plus, and you're trying to figure out what to add, equals 144 plus, and you can start the problem just like that, okay? Whereas in this one, when you get to 16, you have to add the 35 first. So, when is this assignment due? Not until Wednesday. So you actually have tonight and you have tomorrow. So if those of you are pretty busy tonight,